Hi, I'm Mike, and on this installment of Summit Quick Flicks, we're going to talk about selecting the right torque converter for your vehicle. Selecting the right torque converter for a vehicle can be critical to a vehicle's performance and overall acceleration as an end result. It is difficult for a lot of customers to select the proper torque converter because they don't understand how a torque converter operates. What we're going to talk about today is the function of a torque converter, what it does, and how to go ahead and select the proper torque converter for an application. So before we go about selecting a torque converter for an application, it's important that we understand how the torque converter operates and what a torque converter actually is. Torque converter is a fluid coupling device that's going to go ahead and transfer power from the engine to the transmission. It's also going to multiply the torque being created by the engine. What this does is it gives us the ability to leave the vehicle in gear and come to a complete stop at the same time. Now, what makes this possible in the torque converter is the three components that it's made up of. Torque converter as a whole is going to look like a fairly simple device, and internally it actually is fairly simple as well. What you're going to have an outer shell that's going to attach on the back side to the flex plate assembly. But as we dissect this torque converter, you're going to come to find that a torque converter mainly operates off of fluid motion and centrifugal force. What we're going to start with explaining is the fluid impeller. And that's going to be the front shell of the torque converter assembly. This is the only part of the torque converter that is physically attached to the engine and is in constant motion with the engine because it is welded via this seam to the complete assembly, which is going to go ahead and operate off of flex plate motion as the engine is rotating. What the impeller's job is to go ahead and create fluid motion inside the torque converter to create that transfer of power. These fins will catch the fluid that the converter is filled up with. Then it will go ahead and send that fluid through the torque converter assembly itself. The next part of the torque converter we're going to discuss is the stator. The stator is a part that goes ahead and redirects fluid flow towards the impeller for a quicker reaction of the torque converter and for better torque reaction in general in the torque converter itself. Followed up by the turbine assembly. The turbine assembly is the part inside the torque converter that actually transfers the motion between the engine and the transmission. This is the part that engages with the input shaft via the spline shaft internally. And what it's doing is it's catching the fluid motion created by the impeller that's being forced against the turbine and then transferring that power and torque to the transmission assembly. We can go ahead and alter torque converter stall by changing the fin angles, the size of the torque converter, which is going to go ahead and affect the amount of fluid flow throughout the torque converter assembly itself. This in turn affects how high a torque converter stalls, how quickly it reacts or how slowly it reacts, and this is what makes it such a critical component when making engine changes, when changing camshafts in an engine, and determining how a vehicle is going to go ahead and accelerate from a dead stop. So now that we understand how the parts inside of a torque converter actually operates and what it actually does, we got to understand what stall speed really is. Stall speed is basically the term that refers to the RPM in which the torque converter is transmitting all of its torque throughout the transmission assembly. There is a point in which the converter is going to be slipping prior to this that's going to go ahead and let the engine reach its RPM band at a quicker rate of speed to bring it up to the point in which it makes its power. That's why a torque converter must have stall for it to operate correctly in an automatic transmission application. Now, torque converters do have two different types of stalls that they can produce, and a lot of times there's a little confusion between the two and the accuracy of one compared to the other. The first type of stall that most people tend to measure a converter by at home, let's say they have their vehicle at home, they put a new converter in and they want to test the stall rating of the converter, they're going to go ahead and test it via foot brake stall. And what this essentially is, they're going to go ahead and put the converter in the vehicle, go out start the car up, get in the driveway, hold the brake pedal and the gas to the floor at the same time. Now, one of two things is going to happen at this point. Either one, the engine's going to quit making RPMs way before its max RPM point, or two, it's going to break the tires loose and override the brakes at some point in time in the RPM band. This is what's known as foot brake stall. Foot brake stall is actually a very inaccurate way to measure torque converter stall. It's always going to happen much sooner than the other type of stall that a torque converter is going to produce. And it's actually harmful and dangerous, because what it does is it overloads the torque converter, creates a lot of excessive heat and a lot of excessive wear and tear on the torque converter itself, and actually will shorten the torque converter life. So when you do something like a torque brake on a vehicle with an automatic transmission, essentially what you're probably going to end up happening is you're going to end up damaging the torque converter in the long run. The other type of stall that a torque converter is going to produce is what's known as flash stall. Flash stall is the actual stall of the torque converter that the torque converter is rated at, that you're going to see advertised either on our website or in the catalog. And what you'll notice about the stall of a torque converter is it's always listed in range. There's no such thing as a specific 3500 stall converter. It's going to stall around 3500 RPM depending on certain attributes of that vehicle. Whether it be the vehicle weight, the gear ratio, the tire size that's used on the vehicle, the amount of power that's produced by that engine. Those are all going to have an effect on the stall point of that converter. The flash stall rating is the only true rating of that torque converter, though. The actual only true stall rating that you're going to find on a torque converter. This is typically much higher than what the foot brake stall is going to be, and it is going to be much more accurate, and it's actually much harder to figure out at home after the torque converter has been installed in the vehicle. It essentially is the point from a dead stop when you were to just go to full throttle without the brakes engaged, the point in which the tachometer needle is going to jump, and then the transmission engages and the vehicle accelerates. Catching this and figuring this out is kind of a tough task at home, and it leads to a lot of confusion when people try to go ahead and look at the stall that's being produced by the converter at home for personal use and a specific application. So as we understand flash stall, we now begin to understand why it's kind of difficult to select a torque converter for an application, because of all the different variables that can have an effect on the stall range and stall rating of a converter in a specific application. There's a lot of contributing factors to determining what stall converter is going to be right for our vehicle, and selecting the right one is critical to a vehicle's performance and how it accelerates, especially in a drag race application in which 60-foot times are very important and can have a considerable effect on the end result as far as quarter-mile times go. The main contributing factor to determining what converter stall is right for an application is the camshaft that's installed in that engine. Every camshaft is going to have an RPM starting range in which it starts to make power. Now, this can be affected by the cubic inch displacement of the engine, as well as the vehicle combination as a whole. Mainly what we'll suggest to most customers, though, and what we suggest that most of our sales representatives do, is they look at the starting RPM band of that camshaft. Then we'll go ahead and select a converter that is 500 RPM higher in stall range than the starting RPM of the camshaft being used in that engine. Without this critical information about the camshaft, it becomes difficult to select a torque converter accurately for a vehicle and engine application for any customer. One other thing that was mentioned was that the gear ratio, tire size, cubic inch displacement of the engine can also have an effect on the torque converter stall. All of these are not going to have a great effect, but they will have a small or slight effect on the way the torque converter reacts in a vehicle application. Some things to kind of consider is if you're putting that torque converter behind a big block in comparison to a small block, typically it will stall about 300 RPM higher behind the big block application in comparison to the small block application. And this has a lot to do with the amount of torque production of a big block type engine. It produces much more low end torque, so the converter has a harder time keeping up with that torque multiplication that's happening, so it inherently makes it stall at a higher stall speed. It's not going to be greatly noticeable, but it's significant to know. This is part of the reason why torque converters are listed via range instead of a specific number. Things like gear ratio. The numerically higher a gear ratio is in that vehicle, it's going to stall sooner because the vehicle is going to have less load on it to get it to move forward. It's going to motivate itself to move forward much more easily. Same thing goes with tire size. Tire size is going to have an effect on the gear ratio of that vehicle. So if you had, let's say, a set of 373 gears, and you change from a 28-inch tall tire to a 26-inch tall tire, now what you may notice is that the torque converter is now stalling at a sooner point than it did previously because the vehicle is having an easier time moving from a dead stop. The other consideration is that you want to make sure that your torque converter stall range is going to be below the cruise RPM of the vehicle in a street application. This is another area where gear ratio comes into play. Because if the torque converter stalls higher than what the cruise RPM is, let's say on the highway at 70 miles per hour, what's going to happen is it's never going to go in the full engagement point or stall. What that means is that the torque converter is continually going to be slipping. Not completely. It may be slipping at a percentage of, let's say, 20% or so. But that 20% is creating friction inside the torque converter as well because the components essentially are not meshing up with one another. They're not rotating at the same speed. So now what you have is you have a turbine that is spinning at a different rate of speed than the impeller of the torque converter. What this does is it creates excessive heat. That excessive heat creates wear, and what can happen is you may break a weld on the snout, or you may damage the internal components because of the excessive heat, which inherently is then going to damage the internal components inside the transmission because the transmission has a certain RPM operating range that it wants to operate in temperature-wise, which is typically anywhere between 170 to 210 degrees, much like your engine. So what are some symptoms of having the wrong torque converter for a vehicle? Stall is too low. Engine shuts off when put into gear. Very poor acceleration. Vehicle lunges, tries to override the brakes essentially when put into gear. If the stall is too high, the engine will have a very small operating range. The converter never reaches stall at the cruise RPM, or the transmission will overheat or burn fluid due to the converter never stalling. So in summary, the general rules of thumb for selecting a torque converter for a street application are: select a converter that stalls roughly 500 RPM higher than the starting RPM of the camshaft. Remember, converters installed in big block applications typically stall 300 RPM higher than if they were to be installed in a small block application. And always choose a converter that will stall below the highway cruise RPM. This can be determined by knowing the gear ratio and tire size. If this is not done, torque converter life will be shortened considerably. For more quick flicks, visit the Summit Racing YouTube channel. Visit Summit Racing online at www.summitracing.com. Follow us on Twitter at twitter.com/SummitRacing, or like Summit Racing on Facebook at facebook.com/SummitRacingEquipment.